Welcome to the 11th part of VCAA Specialist Math 2022 exam papers. In this video, we will present exam paper 2, section B, question 4, which consists of 4 parts. As for part A, the complementary angle theta equals 78.9 degrees was the most frequent incorrect response. Part B, section 1 was well responded to, including by some students who did not find the velocity correctly in part A. However, some students with the correct minimum speed gave other incorrect values of t in section 2. As for part C, apart from the usual approach, a small number of students approached the question using perpendicularity, which was less successful. In part D, some students responded incorrectly where they found the straight line distance between the endpoints of the triangle. Some students used the Cartesian form of the curve to find the integrand incorrectly using the time values. Welcome to this VCAA Specialist Math exam paper series. This is section B of 2022 exam 2 paper. There are total 6 extended response questions in section B. In this video, we will present the 4th extended response question, in which it states that a student is playing mini-golf on a day when there's a very strong wind, which affects the path of the ball. The student hits the ball that at time t equals 0, it passes through a fixed origin O. The student aims to hit the ball into a hole that is 7 meters from O. When the ball passes through origin O, its path makes an angle of theta degrees to the forward direction as shown in the diagram. The path of the ball t seconds after passing through origin O is given a position vector r of t, which equals 1 over 2 times sine of pi t over 4 I plus 2tj. Here time t is within a closed interval from 0 to 5, and I is a unit vector to the right, perpendicular to the forward direction, while j is a unit vector in the forward direction, and the displacement components are measured in meters. This question contains 4 parts, and part A is to find the angle theta. There are 2 sections in part B, and the first section of part B is to find the speed of the ball as it passes through origin O. The second section of part B is to find the minimum speed of the ball in meters per second, and the time in seconds at which this minimum speed occurs. The question in part C is to find the minimum distance from the ball to the hole, and part D is to find how far the ball travels during the first 4 seconds after passing through origin O. Now let's come back to part A of this question. Since vector r of t equals 1 over 2 times sine of pi t over 4 I plus 2tj, its velocity vector v of t equals dr by dt, which equals pi over 8 multiplies cosine of pi t over 4i plus 2j. So v of 0 equals pi over 8i plus 2j, which gives theta equals 90 degrees minus arctangent of 16 over pi, which approximately equals 11.1 degrees. As for section 1 of part B, the speed of the ball when passing through origin O can be found through the results in part A. Since vector v of 0 equals pi over 8i plus 2j, the speed of the ball when passing through origin O equals square root of the sum of pi over 8 all in parentheses squared plus 2 squared, which approximately equals 2.04 meters per second. Section 2 of part B is to find the minimum speed of the ball. And since v of t equals pi over 8 multiplies cosine of pi t over 4i plus 2j, the speed of the ball equals square root of the sum of pi squared over 64 multiplies the square of cosine of pi t over 4 plus 4. Hence, when the square of cosine of pi t over 4 equals 0, which implies when t equals 2 seconds, the speed of the ball reaches its minimum, which equals 2 meters per second. Now, let's come to look at the question in part C. Here we assume the distance from the ball to the hole is z. Since r of t equals 1 over 2 multiplies sine of pi t over 4i plus 2tj, the distance from the ball to the hole can be expressed as z equals square root of the sum of 1 over 2 times the square of sine of pi t over 4 plus 2t minus 7, all in parentheses squared. Hence, we differentiate z with respect to t, which equals pi times sine of pi t over 2 plus 43t minus 112 all over 16 multiplies square root of the sum of the square of sine of pi t over 4 plus 4 times 2t minus 7 all in parentheses squared. After being equated to 0, the value of t is calculated using CAS calculator, which approximately equals 3.517 seconds. Substituting the value of t into the expression of z of t, the minimum distance from the ball to the hole is obtained, which approximately equals 0.188 meters. Since the question in part D is to find how far the ball travels during the first 4 seconds after passing through origin O as shown in the diagram, according to the vector r of t equals 1 over 2 times sine of pi t over 4i plus 2tj, we have x of t equals 1 over 2 multiplies sine of pi t over 4 and yt equals 2t. Hence, x prime of t equals pi over 8 times cosine of pi t over 4 and y prime of t equals 2. So the distance traveled during the first 4 seconds equals the integral from 0 to 4 of square root of the sum of squares of x prime of t plus the square of y prime of t with respect to t. After substituting the x prime of t and y prime of t for pi over 8 times cosine of pi t over 4 and 2 respectively, the distance d approximately equals 8.077 meters.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.